This video will be on section 8.3, quadratic functions and graphing. We'll start with the definition of a quadratic function, and we'll pretty much jump into the graphs of quadratic functions, their important properties. Really, by knowing how to solve quadratic equations, we could figure out a lot about them. But the other important thing new in this section are what the graphs look like. Right, so the definition, we kind of mentioned this before, what a quadratic equation is. A quadratic function is a function f such that f of x equals ax squared plus bx plus c, with the one condition that a does not zero. Right, so a quadratic function is one where you see an x squared and it's the highest power of x. So the way I like to think about it, we must have an x squared, can have x and just a number. That's what the c is, and then the b times x would be where the x goes. But you must have the x squared. So just take a look at a few examples to make sure we know, what I'm referring to here. So the first one, f of x equals 1 minus x squared. This one is a quadratic function. Why? Because we do have an x squared. And then, really that's the highest power of x. All right, when I refer to powers, I do mean no fractions, just whole numbers. I should write that. All right, so we do have an x squared. That's the first thing you look for. If there isn't an x squared, you're automatically not having a quadratic function. So the second example down here, f of x equals 3x plus 4 is not a quadratic function because we need an x squared and we do not have one. And then the last example I have here is just to reiterate what I've already written up here. So we do have an x squared. We got negative 2x squared in this last example, but we have an x cubed, which is bad for asking this question. We cannot have x cubed, so it's not a quadratic function. Right. Now, the other thing I want to mention, the x squared, the highest power of x can be anywhere. If you like to put the highest power in front, you can just rearrange this to negative x squared plus 1. But they're the same thing. So don't look for x squared to be in front. The order that the powers of x are written in does not matter. All right, so the next thing is, what do the graphs of quadratic functions look like? There's really two possible shapes. They ultimately have the same shape, but one's just the other one flipped. I'll go ahead and write down the f of x equals ax squared plus bx plus c. And there are two examples. The first one is when a is greater than 0, a is positive. It doesn't matter what b and c are for this. They can be anything. They can even both be 0. A must be positive. Then it has an upward U shape. And this U shape is called a parabola. Right. And there's really one major thing about parabolas that we need to point out. A lot of things branch off from here, but it starts at this spot in the middle, at the bottom. This is called the vertex. I like to label it with the letter V just because it's, it's an important point. And a couple things about the vertex. One is, how do you figure out the vertex? For the vertex formula, the x value you get as negative b over 2a. And the vertex is a point. The y value is what you get when you plug in the x value. So we'll see with examples. But for the vertex, you figure out x by doing negative b over 2a, b being whatever number's here, a being whatever number's here, and then plug that result in to get the y value. Really, the only other thing that's we need to point out right now, I guess kind of two things. One is that the vertex is kind of where the parabola gets split in half, and it's symmetric about this line, meaning the left side and the right side, if we reflect it over, it looks exactly the same. This is called the line or axis of symmetry. And it's a vertical line, so as x equals, it's going to be the same number because it passes through the vertex. But it's given as an equation, not a number. Right, one thing that's important, though, is when you do a lot of the problems in this section, you'll find the vertex and the line of symmetry. Realizing that if you've done one, you've done both is a very important thing. Right, now, the last thing, this is going to be the main thing that ends up being different from the other picture we're going to have, because the shape is going to be flipped, is that the vertex down here, it's at the bottom of the graph, is a minimum. When a is greater than 0. There's a lot of ways to kind of help yourself remember that. If you remember, it opens up, and kind of draw it on your paper to remind you, or close your eyes. If it opens up, you know the vertex is going to be at the bottom. The other one's going to open down, as we will see. And this is really the only place where it's opposite. So when a is negative, when a is less than 0, the picture is pretty much the same, it's just flipped. We haven't specified anything about what A, B, and C are, so I'm just drawing a generic shape. It's an upside down U. It's still called a parabola, it opens down instead of up. The middle point here, wherever it is still called the vertex. It just happens to be the top here. The formula for the vertex is exactly the same, so I'm just going to draw an arrow to that. The line of symmetry is also exactly the same as far as the formula. Right, so everything's the same except that because it opens down instead of up, the vertex is at the top. The vertex is at a maximum. Right, and if you think about A being negative, opening down, upside down U, there would be the top of the graph. So that's another way to kind of help yourself remember it. Right, these are all the important features: the vertex, the line of symmetry, and whether it's a maximum or minimum. The one thing you really have to remember is which way does it open. Now, there are ways to figure out which way it opens otherwise, which we'll go through when we kind of graph them a little bit in this next example. So this problem says, use the graph below to sketch a graph of the following quadratic functions. Additionally, give the vertex, equation of the line of symmetry, and the maximum or minimum value. Right, it's only going to have one because it either opens up or down. So you have to pick one of those. But I will remind you the maximum or minimum value is, if you remember back a couple weeks, it is the y value. All right, so if you have to graph a parabola, what should you do first? First thing you should do is figure out the vertex. Right, it's such an important point that that's what you should figure out. You don't even need to point out whether it opens up or down, but knowing which way it's supposed to open will help see if your picture makes any sense at all. All right, so first we want to figure out the vertex. Well, the formula for that, x equals negative b over 2a. I guess one thing as a side note, I usually mention this, so I want to go ahead and mention it now, where the vertex formula comes from. It actually comes from the quadratic formula. And the reason I like to mention that is most people that forget this formula remember the b and the 2a, but forget the negative. So what does the quadratic formula look like? It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And the vertex is kind of, if you threw away the square root part, negative b over 2a. So if you remember the negative on the quadratic formula, you remember the negative, or you remember the vertex comes from the quadratic formula, maybe that can help you remember. Don't forget the negative. All right, so for our problem here, negative b over 2a, what is a? A is the number multiplying x squared, which is 1/2, and b is the number multiplying x, which is negative 3. Now we don't need c here, but let's go ahead and write it out. C is the number by itself, 3/2. Right, but we want to plug in our b and our a. So we got negative, b is negative 3 over 2 times a, which is 1/2. Now, one thing that you can notice here is that if we focus on simplifying this part, the bottom first, since there's a fraction, the 2 and the 1/2 just become 1. So it's pretty quick. There's not going to be a remaining fraction. The top, because we have negative, negative becomes positive 3, and the bottom is 1. 2 times 1/2 is 1, and 3 over 1 is 3. So once again, that is just the x value of the vertex. Oops, God, still all in range. To get the y value, we plug in our number 3. I guess our function is given the name h, so let me rewrite that. We want to plug in 3, the x value we got. Right, so there's not a formula for the y value. Well, there is, but it'd be very incredibly hard to memorize and useless to memorize because you should just do this every time. Plug in 3 and simplify. Got 1/2. 3 squared is 9, minus 3 times 3, which is 9, plus 3/2. And simplifying the front here, 1/2 times 9 is 9/2, minus 9 plus 3/2. Now what you might be thinking is find a common denominator now, but you don't need to do that unless if all the fractions have a different denominator. Since these two have the same, combine them first and see if it simplifies, since they already have the same denominator. And so 9/2 plus 3/2 is 12/2. And then we have our minus 9. And you see the reason this works out so well is 12 over 2 is 6. So the fraction actually goes away without needing a common denominator, and 6 minus 9 is negative 3. Now when it comes to finding the vertex for a parabola, really this is always the main work, is figuring out the vertex. Everything else is very similar to it. And also, if there's not a fraction, it's a lot quicker too. All right, so the vertex is a point. The x value is 3. The y value is negative 3. And then you want to plot this first when you graph. All right, so to graph this, you want to use the parabola, one that looks like a parabola graphing tool. And plot the vertex first. So we got a point at x equals 3 and y equals negative 3. Now your computer won't do this, but I just like to label it, since when you do it on the computer, it's just going to fill out the whole thing, but we don't want to get it backwards. Then to finish graphing, plug in another x value. Now the one thing that's going to happen on these is that when you graph them, you have to get a whole number to plot them. So to finish graphing, plug in another x value that has a whole number y value. Now, in general, what I always recommend is plugging in an x value that's just 1 away from the vertex, so 2 or 4, it wouldn't matter which one. Since the denominator, the least common denominator is 2, you want to plug in one that's 2 away. Now, like I said, as another little comment here, not all of them have fractions. If there's no fractions, just plug in any number at all, but I would plug in 1 right next to it. Right, and also I want to reiterate something that you've seen with the homework in this class, is that they all have videos attached to them. So if something seems off, if you feel like you haven't seen a problem, it's probably very similar. Maybe watch the video very quickly to get yourself up. All right, so I'm going to plug in a number that's 2-way. That means I can plug in 1 or 5, and it won't matter. I'm going to plug in x equals 1. And we get h of 1 equals 1/2 times 1 squared minus 3 times 1 plus 3 halves. One half times 1 squared, well, 1/2 squared is 1. Not times 1, but we just will for now. Minus 3 times 1 is 3, plus 3 halves. And 1/2 times 1 is 1/2. I'm going to do the same thing I did with the previous part and combine these, just like last time, because they have the same denominator. 1/2 plus 3 halves is 4 halves, minus 3. This is 2. 2 minus 3 is negative 1. So the other point I'm going to plot is x is 1 and y is negative 1, which is right here. Now you must do the other point second. If you do the vertex second and this one first, it will assume this is the vertex. So you got to do this one first, the vertex first, and this one second. Once you do that, it will make the parabola for you. Since this point is above the vertex, it's going to open up. So it kind of makes that U shape. And because it's symmetric, it'll trace this other side out perfectly. right, so we've made the graph. And as far as the questions go, we've found the vertex. Everything else asked is based on this. The other two things, we want the equation of the line of symmetry and the maximum or minimum value. So the equation of the line of symmetry, well, remember it's just a vertical line the vertex passes through, so it's x equals the x value of the vertex, which is 3. You don't have to do any work here. And then finally, the last part here, the maximum or minimum value, since it opens up, or a is positive, we have a minimum value of, and then it's the y value of the vertex, which is -3. All right, so I know there was a lot of information in this problem, mainly because of how to use this graphing tool. But, excuse me, once again, really this part of the work, plugging in the 2 points, is only so much work because of the fraction. If they're whole numbers, it's a lot quicker. So use your formula to figure out the vertex, plot it, plug in another number, plot it. It'll make the chart or the graph. You must select the correct graphing tool though. Then after that, you really have everything. You already got the vertex. We want to get the line of symmetry, which is the x value of the vertex, but it's the equation, and the maximum or minimum value is the y value of the vertex. All right, so for the rest of this section, which is really just the same thing but without graphing, kind of try to get you to do these new ideas but without a graph. For the following quadratic function, determine the x-intercepts, y-intercept. I'm going to color code all this since there's a lot of parts to it. The vertex, and the equation of the line of symmetry of each. So this one doesn't ask for maximum or minimum, it doesn't ask us to graph it, but it does ask us for the intercepts. Now, x-intercepts, this is usually where a lot of the work can come into play because of how you find x-intercepts. Remember, to find x-intercepts, we set y equal to 0, y being g of x, in this case, the name of the function. So we have 0 equals -2x squared plus 4x plus 7. And to get the x-intercepts, we have to solve this. No, but not for y, we want to solve for x. And this is something that before this module, we had to use the quadratic or factoring. Now we can, if we can't factor, use the quadratic formula. So you either use factor or quadratic formula. For this one, I believe only the quadratic formula works because when we multiply -2 times 7, we get -14. And we're not going to find two numbers that multiply to -14 and add to +4. 7 and -2 are the closest, and they add to 5. All right, so let's go ahead and solve this using the quadratic formula. So yeah, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, I can go ahead and just do this one right now because it's equal to 0. All right, so let's go ahead and plug it in. B is 4, so we got -4. plus or minus the square root of 4 squared minus 4 times a, which is negative 2, times c, which is 7, all over 2 times a, which is negative 2. And like we learned in the last section, to simplify this, do the inside first. And if you want to do that in a calculator, that's okay. So you got 4 squared minus 4 times negative 2 times 7 is 72. We got negative 4 plus or minus the square root of 72 over negative 4. We've seen something like this before. Do not cancel this out because you have the plus or minus here. So we cannot cancel that out. Now we want to try to simplify this. 72 does have a perfect square in it because it's 36 times 2. Right, so just dragging this along, negative 4 plus or minus the square root 72, we're thinking about is 36 times 2. And then we break up the square root. The square root of 36 is 6. And the 2 is stuck inside. And remember, this is where we split it up into 2 fractions. So the square root is simplified. Now we split it into 2 fractions. And so we got negative 4 over negative 4 plus and minus 6 square root of 2 over negative 4. Now we can simplify or cancel the negative 4's over here because it's just one part in each fraction. We got 1 and 1, so that becomes 1 plus or minus the 6 and the 4. We can take a 2 out of each. 6 becomes a 3, 4 becomes a 2, and we got plus or minus. If you'd like to move the negative up front or up top, go ahead. 3 square root of 2 over 4, over 2. And then finally, each fraction is simplified. Now split up the plus and minus. And we got x equals 1 plus negative 3 square root of 2 over 2, and 1 minus negative square root of 3 over 2. Wow, that's not at all what that says. It's negative 3 square root of 2 over 2. I'm going to change the minus minus to a plus. So these are the x values of the x-intercepts. Remember, the x-intercepts are coordinate pairs. We do x value comma 0. So we got 1 plus a negative is just minus 3 square root of 2 over 2 comma 0. And 1 plus 3 square root of 2 over 2 comma 0. Now, unfortunately, this one didn't simplify that much, but that is the simplified answer for the x-intercepts. And also, that's how you can use the quadratic formula to find the x-intercepts. All right, next, the y-intercept. Y-intercept we know is usually much easier because what do? We set x equal to 0. We take our equation, we got y equals negative 2 times 0 squared plus 4 times 0 plus 7. And this boils down to just being 7. We got that simplified. We have our y-intercept. Just make sure you don't forget that it's also a coordinate pair. X equals 0, y equals 7. Every parabola has exactly one y-intercept. No more, no less. The third thing here, the vertex. Let's scroll down to make some room. Remember the vertex formula is x equals negative b over 2a. Our b is 4 and our a is negative 2. We're going to plug those in. B is 4, a is negative 2. And simplify. 2 times negative 2 is negative 4. Negative 4 over negative 4 is 1. Then we plug in 1 to get the y value of the vertex. Our formula was negative 2x squared, x is being replaced by 1, plus 4 times x, which is 1, plus 7. And here we got 1 squared is 1, so we got negative 2 times 1 is negative 2, plus 4 times 1 is 4, plus 7. And this equals 9. 4 plus 7 is 11, minus 2 is 9. Right, but like with the x and y intercepts, the vertex is a coordinate pair. You have to write it as a coordinate pair. X is 1 and y is 9. And finally, the last thing is the equation of the line of symmetry. There's only one line of symmetry. Oops. No. And the line of symmetry, remember, if you found the vertex, you found the line of symmetry, it's x equals 1, but you need the x equals part. Right, so I'll just reiterate that. You need the equation, you need the x equals part, just 1 is incorrect. Right, but as far as parabolas, the graphs of quadratic functions go, that's all there is to it.